I can actually hear myself, finally. Okay, advanced audio properties.
Testing. Finally. Sorry about that, guys. It was the microphone that was refusing to work for some reason. So, as usual, we're gonna look at find some drum and bass music so we can listen to today. I guess Twitch streaming. Okay, and hopefully this is not too loud. So yeah. Okay, myself. This is testing. Let's see what I sound like when the music is also paused. Okay, myself. This is testing. Let's see what I sound like when the music is also paused. Yeah, we are ready to actually begin the stream. Welcome to another stream. We're actually tuning in just before Christmas. And I'm happy to see you guys again here. Okay, let me get the chat up as well. And yeah, I guess we can begin. Right, so in today's stream we're actually going to be doing some more C++. As you can probably tell from the video, we're going to be looking at writing some WebAssembly or porting things to WebAssembly. And I just realized that this is too loud here, so I'm going to turn it down a little bit. And let's hope to God that we don't get the CMake strike here. So yeah, we're going to look at turning one of the libraries that I've written before in C++. More specifically, it's a base64 library. And we're going to be compiling that with Emscripten. And yeah, I'm excited to do this. So let's actually go and take a look. So first of all, we're just going to show to you guys what the library is. So we have this base64 PP library here, which is somewhat, I guess, popular for my standards. It's actually got quite a few stars, probably the most stars I've ever got in the GitHub repository. But this library is simply a modern implementation of base64 in C++, and we're going to be turning this library into, I guess, WebAssembly, so we can call it in the browser. Yeah, so let's go. So the very first thing is actually to, I guess, read some of the WebAssembly, right? And I've got here this tutorial I actually found on the WebAssembly developer, the Mozilla developer website, which kind of shows you how to compile the libwebp library to WebAssembly. So if you don't know what libwebp is, it's just an image library. It reads the WebP format. I'm going to drink some water. And yeah, let's kind of follow this and see if we can do the same with our library, right? Which should be fairly easy. And then perhaps in the end, if we have time, we can actually look into maybe pulling a dependency with Conan, something like libjpeg or libpng, to keep in this sort of like C library like standard, and then we can compile that with Emscripten as well. I believe I already have Emscripten installed here. Let me check that, because I have done a stream before with Emscripten. CMake or something. Yeah, see, I don't know if I actually do have it installed. Maybe I don't have it. So that, you know, it's a good thing to actually try and install Emscripten. So let's do that. I think that previously when we did a stream where we compiled some code to WebAssembly, it was on my Raspberry Pi, so yeah. Install the SDK. First of all, do we have this? Oh yeah, we do have EM SDK. So we must have already installed this before. cd EM SDK, and then what do we do? So setting the following tools as active, releases or whatever, Node.js. Conveniently access EM SDK tools from the command line. Consider adding the following directions to your path. I guess we can do that. Peter, hey Peter. You are actually on late today, am I? No, you're not late, man. It was an impromptu stream. And I pretty much started streaming like 10 minutes ago, so you're pretty on time, dude. It might be a late one today as well, so we'll see. Depending on how much work I get done here. So yeah, I mean, we're doing some WebAssembly again, Peter. I actually want to learn this. It seems to be gaining popularity, so yeah, let's add these to our path, right? So if we do, first of all, let's open a new terminal here, and let's vim our Z shell RC. Okay, cool. And then we can add it to the path. Okay, so let's begin by doing this one. And then the last one here, which would be this one. Okay, and then we can resource it. As that shall I see. And we should have the tools now. So activate path and other environment variables in the current terminal. Yeah, we already did that. Let's see. Right, let me answer that myself. Having a fast currently, but I'll be here too. Thank you, man. Thank you for giving me the little audience. I do appreciate the numbers. I just want to say as well, man. It probably will be the last stream that I kind of do before Christmas. I don't know yet. We'll see. Well, you know, thank you very much for tuning in this year, and it's been a pleasure knowing you guys. So I do appreciate all the support. And who knows, there may be a giveaway on the Discord soon. So I'll talk more about that in the following days. Maybe win something, Peter. Who knows? So EM SDK install targets. You can also specify a version, okay. I'm enjoying these songs, but I kind of feel like I'm going to get a strike soon, but I don't really care. Not for this stream anyway. Placing the SDK, okay. Cool. So we have all the binaries here, and okay, cool. There you go. CMake, that's the one. So in theory, I should be able to do EM. Well, if I resource my bash, my Z shell RC, should be able to do EM CMake. Yeah, there you go. That's all we needed for now, I guess, because we have access to the CMake bundled with Emscripten, which sorts out all the compilers and stuff for us. So yeah, I mean, in theory, right, if this tool is really good, we should be able to go into my project. Let's check out main, I guess. And pull it. So yeah, in theory, we should be able to just build this with the CMake. So let's see which version we are. CMake version. CMake. So it's 3.27, which is a fairly new version of CMake bundled with it. So we should be able to do something like, you know, preset, Unix, release, right? Hopefully. There you go. Yeah. That's good. That's good. Yeah, and because I don't have any sort of dependencies with Conan or anything like that, this should just be, you know, a walk in the park. Which is cool. Now, if we do CMake build, we can see if it's going to work. Okay, I mean, it generated a file. So if we go into build, we've got a Unix release here. We've got lib-base64 pp.a, which is a static library. But I mean, this is still in the binary format, right? So if we do a file on lib-base64 pp, yeah, it's just an archive currently. So how do I actually get, you know, this is my next step. How do I actually get the WebAssembly file so I can run it on Node or something? This is what we're gonna see, I guess. So this is just compiling with whatever, with the actual compiler. Exports runtime methods wasn't equals 1. You only need some HTMLs and JavaScript to load your new module. Yeah, I mean, we still don't have a good enough file, I guess, to... we still have the .a file. So how do I compile CMake project with Emscripten? Let's see if we can get a separate or a different tutorial that will actually tell us exactly which flags we need. In the CMake root directory, set the CMake toolchain by running this. Okay, compile to WASM. Maybe that's what we're missing. We can try this, I guess. I'm also taking a look at the JavaScript that they've got here. Yeah, it does seem that it is some sort of shenanigans to actually kind of get the executable suffix here, so JS. So I guess I do have to kind of make my library support Emscripten, right? So we can kind of do something similar here. I suspect the path doesn't include CMake. Try running this from terminal. Yeah, because it seems to me that we have to add all of these CMake executable suffixes here, and the properties and the flags here as well. But we can do this on the CMake presets, right? So let's actually begin by creating a branch where we can support that. So we have pulled already, and we can check out a branch here. Let's call it Emscripten support, right? Emscripten support. Okay, so now we have a branch for this, which means we can kind of make some changes here. So let's open this on code. And as always, when I'm actually supporting a different type of build, or a different platform build, or a different build type, I would probably begin by actually, it's the wrong file, by changing the CMake presets, right? That's what you should be doing nowadays anyway. So just to make sure, like, you guys understand, since we're adding a new different type of compilation here to our project, which is not a sort of like a Unix or a Linux compilation or a Windows one, we're building for the web. That means we probably want a new CMake preset for it, right? So we've got it here, release and whatever. What we could be doing is fudge all of these guys, and then we're actually gonna just add our Emscripten here, maybe before the. So yeah, let's begin by giving it a name. So let's call it Emscripten. Display name. Let's call it, Emscripten WebAssembly. We need a binary dir, I guess, which is where everything's going to be, added to. Here we can add the source dir, which CMake resolves as the root directory of the project. Build Emscripten. We don't want to inherit anything here. We just want to put some extra cache variables. And this is where this little tutorial comes in, or this little snippet here, because I'm just going to steal these settings, because that's what we basically have to set. So essentially, we just want to set that as this now. What else do we need? It's JS only. Else JS only. Setting the compilation to wasn't. I guess I'll do wasn't.js, right? I mean, I don't know the difference that we have, between these two. Yeah. So far, it's just the file name that's going to change. One thing we do have to set as well, from the looks of it, is to set the CMake toolchain file pointing to my installation of the Emscripten, right? So here, I guess it would be, an environment kind of thing. So I do my env and then Emscripten root or something, and I guess I can set this variable somewhere on my machine. But later on, someone does say which toolchain this has to be as well. So let's find that out. So Emscripten CMake toolchain. So it's in CMake, modules, platform, Emscripten.cmake. To use this toolchain file, we CMake, invoke CMake with following commands. CMake the toolchain file. Okay. This is kind of what we want, but obviously without this here. Let's not forget that I need to define this in my bash RC, or my Z shell RC in my case. RC. Let's also export I think that was the no, it was in development. Yo, Slim. Sorry, I just saw your comment, dude. How's it going, man? A long time no see. I hope you're doing great, bro. You can help me learning some Emscripten today. How about that? How are you? I'm good, man. I'm very good. I've been very busy with work this week. Seems like they want to do a lot of like test and stuff. So like I've been non-stop at work, dude. I'm good. Just playing these days. Oh, cool, man. How's work going? I hope work is going good as well, dude. You are the developer, right? I'm not mistaking you for someone else. I think you are the London guy who is also a JavaScript developer or something. Stressful. Understood. Yeah, sweet. I mean, me too, dude. Hopefully you're gonna get some time off. Like me, you're probably gonna get like a week or two off, and you get to chill and do whatever. Like myself, I plan to just switch off work entirely and focus on content writing a little bit. So like I've been editing this video for like literally 2 weeks now, and I can never finish it because whenever I get like half an hour or 15 minutes, like it's never enough time to edit the video. So I just got to sit down one day and then just complete some videos basically. All right, so this is not what the toolchain file is. Is it in scripts? No, also not. So what if I do a find here? .CMake. Anything .CMake. Let's grab tool. Yeah, we don't really have the toolchain file. Okay, yeah. Why can't I find the Emscripten toolchain file? That's what I'm wondering here. Is this person set in it? Toolchain file, upstream, Emscripten, CMake, modules. Okay. So it's kind of here. It is an upstream. Emscripten, CD Emscripten. Ah, okay, yeah, there you go. Found it. The platform, Emscripten, there you go. So we kind of just need this. So the up to here, I guess. Is Emscripten root already kind of set? So if we do echo Emscripten root. Oh yeah, it's not set. That's fine. Anyway, so this is what we want. Up to here. SDK upstream. Okay, cool. Now if we source it again, we should have that variable z shell C. And there we go. So in essence, we have everything for this to work now. Just need to add that, and we can do a CMake toolchain file here. Oh no! It's the wrong one. CMake toolchain file there. Okay. And is there anything else that we need for this compilation to work? Let's figure out. Yeah, so this person is just literally setting the toolchain, and they added an experimental, well, an optional flag here that they control themselves if they want to build for JS only or not. But we need these flags here, so we kind of need these link flags. So what we're going to do is, in the same way, we can just do CMake CXX flags. Yeah, and we can paste those in. Exported functions, those are flags as well, I guess. Yeah, I guess that's pretty much it. So wasm this JS one me. So we wanted to build for WebAssembly, so we do this. Okay, cool. Now there is one thing. I started code before I actually kind of activated Emscripten and created all the environment variables that we needed as well, which is fine. So now we're gonna kind of do the same here for the build, right? So in the build, we're going to just add one of these as well. I will say just Emscripten. Configuration, release, I guess. Yeah. Now let's see if we can call this preset. CMake configure preset. We've got Emscripten WebAssembly here. CMake select configure preset results in an error. What did it result? So generator is not set in configure preset Emscripten. I see. Now this is because I guess that toolchain file is kind of set in the generator. Oh, no, maybe not, maybe not. We can just set it. Where's Unix make files? Unix make files, yeah. I just forgot to define that. Let's hopefully see if it's gonna. Okay, does it work now? Okay. Cool. I mean, it seems to be getting somewhere. Now, if we build it though, is it gonna work? So em++, that's great. So we are actually using warning linker settings ignored during compilation. Wasn't. Unused command. Okay. Exported functions was also ignored, but we should be able to see Emscripten here. And again, we still have a .a library file here. Like, I don't know if I'm right, but this they should be generating a .wasm file for me. What library am I porting? I'm porting a library that I wrote myself. It's a base64 encoder and decoder. So it's this one here. And I'm basically just porting this because it has no dependencies, nothing whatsoever, apart from like a dependency on gtests with Conan on debug modes, but this should be fairly easy to port. And the plan is to just port this to WASM, basically. So that's what we're doing today. And with that, I'm using Emscripten, obviously, as the WASM compiler. So yeah, I want to try something crazy like OCI. Yeah, I mean, I want to try some crazy libraries as well, and then port it to WASM, but I got to start small so I can actually learn how it's kind of working. I'm kind of following the Mozilla tutorials here, but it's kind of shit. I'm not gonna lie. I mean, yeah. I mean, first of all, they're only teaching you, like from the start anyway, they're only teaching you how to run the compiler, not how to run, you know, a full build system with Emscripten, which is, I guess, CMake. Maybe they do get into that, encode the image. Yeah, no, they're not doing that just yet. CMake, yeah, let's just see how to do that. Static library build with CMake as an A with Emscripten instead of WASM. That's my issue. Tell you how do I configure CMake and Emscripten to build my static library to produce WASM instead and JS bootstrap file. You are correct in that you need to create an executable target in order to produce a WASM file. If CMake insists on you creating a dummy source file because it doesn't understand that all the code for your program can come from libraries, then I guess I guess that is the best option. What? Is it possible to build an executable only from static libraries and no source? Okay, so we have to create an executable. That's interesting. Can I not just compile a library? Mind, because I did some detection in Rust. Was I'm using Rust bind gen. Oh yeah, cool. Mind if you send me your playlist, please. Yeah, I can send the playlist. I just googled DCMA's free, like drum and bass, really, but here it is. So I'll link it here. Copy link to playlist. It's the playlist. There. So you prefer Vim to Vi? I actually love Vi because of Betty. Yeah, dude. I've always used Vim, but yeah. Sometimes when you log into a remote machine and it's really bare bones, it doesn't have Vim, so you have to use Vi. And some of the it doesn't have some of the things that Vim does, obviously, because Vim is an extension of it, and you get really annoyed. But let me just reply to a text here, guys, real quick. Yeah, the chat says hi to the person you're texting. Yeah, I'm texting a mate of mine who's asking if I want to chill tonight, but I'm like, I'm kind of on the stream now. So yeah. Anyway, yeah, So yeah, it kind of looks as if I can't really just compile my library to WASM, because what I was thinking of is like maybe if I compile everything with Emscripten, whatever functions and stuff, my library's exposing. It would just be in JS, right? In JS and WASM. But that's not quite right. It seems to only work if you have an executable. Right, this is not WASM at all. I have a static library being built with CMake, but I want to build a WASM library file. And a bootstrap for Emscripten. Simply using Emscripten CMake toolchain and adding the appropriate compiler. It results in only .a file being built, even if /o project.js is added to the compiler and or linker flags. The reason is that I've told CMake I want a static library. Use a CMake AR to build. Yes, that's correct. CMake AR is defined as EMAR in the Emscripten toolchain, and EMAR cannot produce WASM and JS output. I have tried just creating a new executable target that has a dependency on the library, and otherwise just sets the compiler linker flags. However, this causes a CMake error because I've defined an executable target that has no source files. If I add the stub main, I get Emscripten warning. Okay. Yeah, I'm with this guy. I just want to create the library. So compile a library to WASM JS. Yeah, so we've hit the first kind of wall. How do we create a static library from Emscripten? It seems like you can't so far. That's what I'm getting, but we'll keep digging. Keep digging a little bit more.
Tracing city lights.
Did the dummy repo start help you with Emscripten? Oh yeah, he did, dude. I think you were here, right, on that. Obviously we're here because you're the one who suggested the dummy repo, which builds ImGUI, right? ImGUI. That was quite cool. That kind of really showed me the the power of Emscripten, because never in my life I thought you can compile SDL2 and something like ImGUI to the web. So I was really impressed by that. It's partly the reason why I'm kind of doing this today, because I just want to learn a little bit more about it. Maybe you can take the inspiration. Yeah. Nearly worked. Nearly worked. I won't give you that. Has to be an EM, I think. Emspiration. But I think the question is answered if it's open. Peter Nelson. Let's give this guy a chance. Building C and C++ libraries for WebAssembly. One of the main attractions of WebAssembly is that it allows us to leverage the vast library of existing open source C and C++ code in our web applications. Yes, it does. Okay, introducing Emscripten, a tool chain for the browser. I'm not going to read this. Our goal is to produce a WebAssembly module, typically denoted by WASM file extension, that contains and exports all of the functionality from the library we want to consume from JavaScript. Yes, this is what I want to do. Preparing this module will typically happen in two stages. First, we must cross-compile the library to WebAssembly. This will involve using Emscripten build system wrappers, but otherwise is much the same as building the library native. In fact, I found it the same. Plus or minus some configuration changes. Unfortunately, this doesn't usually output a WASM module that we can immediately ship, just like a building native static library doesn't output anything we can run directly. Therefore, we must link together a final WebAssembly module. This is done by either exporting functions directly from the library or by writing a custom wrapper and exporting the wrapper's functions. In either case, the Emscripten compiler will package everything up into a shippable assembly module ready to be consumed from JavaScript. Yes, that's what I want to do. So let's read this. Unless the data types that flow across the library's interface are very simple, you will likely want to go down the wrapper route. Although Emscripten provides the ability to interoperate with native concepts like pointers and memory management, they are fiddly to use. With a wrapper, we can expose our own higher level interface to JavaScript that is easier to consume and hide some of the messier details. This choice is partly subjective, however. Yeah, I mean, with my library, I can do that. I understand what he's trying to say. He's trying to say, like, if you have functions that take really obscure types in C++ or C, or things like pointers, unique pointers, you kind of have to have a wrapper around that for JavaScript and for a JavaScript module. And it's kind of the same thing that Swig does. If you ever did Swig before, Swig is that little tool that compiles or exposes your C++ and C code from these two languages to things like Python, Java. So it's the same sort of logic here. You have to write sometimes an interface file, which is essentially a wrapper around those very complicated types. So the following sections are written for a spherical cow example. As every C library has its own build system and dependency nuances, you will likely have to tweak these steps. The library's own documentation should be your best friend. Yeah. So that if the library has also tools, build systems, then we use Emscripten around. Okay. Otherwise, the library uses CMake will simply use Emscripten CMake. That's what I'm using. That's what I'm doing. Install prefix. Okay, we set the prefix. Okay, for deploying the WebAssembly binaries. Yeah, maybe I can do that as well. Yeah, maybe I'll set this. Just so we can have somewhere that the libraries will go to. Dynamic linking is still a little clunky in WebAssembly, so build a static library if at all possible. Yes, to disable dynamic linking, you have to consult the build configurations options of your particular library. Okay, cool. Yeah, we already build statically anyway, so we don't have to worry about this particular step. The Emscripten runtime technically supports pthreads via web workers. However, there are some caveats due to the asynchronous nature of the browser environment. It's recommended to disable threads to begin with and tentatively enable them again once you have the single-threaded library working. This can be quite a pain if you're working with complex libraries, quite a pain. Also, threads and memory growth together are very slow. To disable threads, consult the configure options. Once configured, we call the Emscripten wrapper around make, CMake, and install it as usual. Okay. So identify the functions that you want to export and thereby make accessible to JavaScript. These might be in your wrapper C++ module if you decided to go that route. Know that C++ name mangling might make function export tricky. Therefore, it's recommended to either write your wrapper functions in C or declare them extern C. We then run Emscripten compiler to link everything and gather to specify our reports, our exports. Input output options. Typically want to specify JS. So here is just explaining what you're going to put into these things. So this is the compiler. I mean, this is what CMake is kind of doing on the background, I would assume here. If we call like CMake verbose makefile equals true or something. Let's reconfigure. I want to see what kind of commands the toolstring file is invoking. So CMake, what the hell is that? Engine directory, Emscripten. Build cd and CMake and script. There you go. It is using the Emscripten ones here. CMake install, is that a thing? Oh, we have an install now. I mean, yeah, we don't really have anything meaningful here though. This is again just the static library. Let's read this a little bit more carefully now. So the input files may either be your C++ or it could be the WebAssembly object files, static libraries that were built. Okay, so maybe we can just call this on the build library, right? Emscripten cd base64. You will typically want to specify JS, in which case use a JavaScript. In which case a JavaScript helper module is also output. Okay. JS. Now the input, they say it could be lib base64 pp.a. And the options could be whatever options you require for your case. This might include flags for linking to other dependencies. Emscripten has built-in support for various common C, C++ libraries, including standard libraries, pthreads, SDL, and a subset of OpenGL. However, if your library has an unsupported third-party dependency, you have to also build them for WebAssembly and link them here. Cool. The dash exported functions options is a list of the functions to make available to JavaScript. Note that you must include the leading underscore that is in the C binary naming convention. For example, if we wanted to export foo and bar, this would have taken the form -foo and -bar. Also note that Emscripten does aggressive tree shaking, so any code that is not ultimately reachable by one of the exported functions will be optimized out as of the results in the library. Okay, so first of all, it seems like I have to kind of figure out what the naming of my functions are in the C. But let's just do it without it. Let's see what happens. So no options, exported functions. What did we have here? Undefined symbol main. Yeah, so it does seem like we do need some sort of we need to understand what we need to write that wrapper for it, basically. That simple wrapper. So Emscripten So exported functions tells the compiler what we want to be accessible from the compiled code. Everything else might be removed if it's unused. And yeah, we need that's the only problem though. We want to prevent C++ name mangling, which essentially just means that whenever you compile C++ down to assembly, it gets a different naming standard than C. So this particular function here, if it's compiled in C, would have an underscore in square root. So I guess we kind of need to do that from our code, right? Let's take a look at the exported code. And I'm just going to do like one function. I'm not going to do all of them. Okay, so for example, we have a lot of string views here. And these are C++ 20 types. Now, for the sake of it, let's add a new one here. Let's call it yeah, but how does Emscripten like C strings? I guess it could do, right? I guess. Oh, well. Let's extend C it. Okay, and now we will add that function here. So something like start string array64 be export encode wasm. And that's simply called the encode with value, right? Notice we'll use find string to span. We don't want a span, we want a string view. Oh yeah, encode string. There you go. And let's see if this is gonna work, shall we? So if we build it. Okay, no, it doesn't work. Warning, wasm encode, a sibling is specified by returns, user defined type, aka base string, which is incompatible with C. Yeah, we can do that. So let's say we return a const car star here. again, the const star there. And then we're gonna return. I'm writing too much Rust, I'm forgetting here. What is that going to return me? Code string? It returns me a string, so C string there. Okay, so warning, returning address of local temporary object. Yeah, so it is. Yeah, this returns a reference or a pointer to a local object that's then removed. What do we do here? What do you guys think? What do you guys think? What should I return? So obviously I can't return a reference or a pointer to a string inside here. Oh my god, can't believe I'm googling this. So return C string from function. Yeah, but I've got the kind of string itself, and I'm returning a pointer to the string. But kind of just want to copy it, I guess, right? Kind of want to copy it to a new. Malloc size T, so we've got the is malloc really not available? Is what's that can be used? Okay, so that's fine. So we've got cast, restrict. Which one is the destination? Interesting. Str copy. So the first one is destination. Okay. So we copy it to rep val encoded dot C string. And we return this. I mean, we're still returning a pointer that needs to kind of be freed. But yeah. I know that there's probably a memory. I've definitely caused a memory issue here, but I want to see if this is not going to compile. This is going to complain. Okay, it doesn't complain now. Yeah, I mean, there is obviously a memory leak here. I'm not sure how Emscripten deals with this. Because you're returning a kind of like a pointer to a string that needs to obviously be deleted later on. So yeah, I don't know how it deals with that. But for now, I'm just gonna ignore the string types here. Let's see. Emscripten string C++. Yeah, we know that we can't. I'm interested to see how people write script, how people expose the strings to JavaScript here though. This is the extra code you need to write to expose your function to JS. My string length function. Okay, so what is this? If you want to use string, then you can use Embind or WebDL binder. Refer here. binding C++ and JavaScript. The web, okay. The Embind can bind almost any C++ code, including sophisticated C++ constructs. Shared pointer. Okay, yeah, I don't want to use this. This sounds like a lot. It sounds a lot better than what I had before. So, yeah, where does this come from though? Which header do I have to include for this? Emscripten bind. Okay. So I have some extra libraries to include to it. So this is kind of what I need here. I'm just going to put it down here. And we can work from here. Module. Make sure you pass the flag bind when calling EMCC. And we also need to have, like, I guess I need to find Emscripten. What was the header again? Upstream Emscripten bind.h. Yeah, okay. First of all, is this naturally kind of included by the toolchain? That's what I wonder. So if we do build, yeah, it does find it. Yeah, cool, it does find it. So IntelliSense-wise, it does work well. My string length, it returns my string length. This is the extra. Okay, so this is the name of the function and the thing itself. Okay, cool. So encode string. Okay, now I do wonder if this is going to work because I've got a string view here, and how complex is the Emscripten binding thing? Does it recognize the more advanced types, more modern types? I guess I'll figure out. So right, let's build it, see what happens. There you go, doesn't work. Why? Error, use of undeclared identifier function. Did you mean? Huh? Okay. Using namespace Emscripten. Yeah. Okay, it's probably because. Yeah. Okay, that did build. Okay, that did build. That's cool. Now the thing is, if we go back into... This is working too well. This is... There's no way this works this well. If we go back to EMCC... Okay, I mean, maybe the function is already exported. So we need to pass the binds. EMCC, Embind. Oh, quick jump. Make sure you pass the flag when calling EMCC. Okay, let's just try that one. Right, this is crazy. There's no way this worked, right? So if we take a look at this now. So Emscripten, and then we have base64pp, testing.json. The module type is undefined. Start script. I have no idea what all of this is, but is my encode string thing in here? It is not. Resulting is a quick example.js, which can be loaded by a node script. Okay, let's try that. Let's try creating one of these. So if we create a new file called testing.html here, and then we simply paste that in there. And instead of quick example, we have testing, right? That's what we had that. So we loaded that up. And how do we actually call this? Like, can we start Node.js here first of all? I'm a bit lost now, but can be loaded as a node module by a script tag. We use onRuntime initiated. Right, cool. Now the thing is, how can I run this as a node module? Because I've absolutely no idea how to even run node with that module enabled. But we do have an example here from the other file, which was from the other program the other day. I just can't remember. Can't remember which project it was, but we do have an example. So not there's me in I am calc, it's not that one either. Web server comparison is not this one. Oh, there you go, this is the one. Because I remember it having some sort of like startup script, and I kind of can just hope that I can copy and paste that for now without understanding much about what's going on. So we can try that. Let's readme. Readme. There you go. Install yum SDK, npx http server. Like, do we have any node people in here? Like, how is this working? What does npx actually do? I guess it starts node with this HTTP web server, but where do we find that? So I guess it's created from here, right? Is there like a node file or something with the settings? AC package installed. HTTPX server. Or is that just the normal one? Ah, okay. This starts a web server from the directory. Okay, so in theory, we should be able to kind of go into my project and then run it from there. So we have base64, we have build, Emscripten, we have base64 here. Good, so I can run something like testing.html, right? Include base64. build Emscripten basics. Where's my testing? Base 64 include. Wait, what? Ah, it's the wrong one, that's why. Sharing build base 64. There you go. I mean, cool. Now, how do I use the function? Let's open the developer tools and JavaScript console. What do we have here? A lot of things didn't work though. Module lerp is not a function. Console module lerp. Ah, okay, yeah. Yeah, we can change that though. Encode string is not a function. Alright. Maybe it didn't work. Maybe it didn't work at all. So we've got function lerp. On runtime function. We have that. We're very close though, because obviously we do have something. We have something that has some JS file. Some JS files here. And WASM, you know, we can't even open that. But I do wonder if that function is compiled into my stuff. So we have base 64 pp. We have build here, Emscripten, and we have base 64 again. What if I do a string on testing? That wasn't. You can see all the types that it's actually kind of. So encode is not a name. Encode is not a name at all. Maybe it didn't work, guys. This is unfortunate. Encode string comes to encode string. What's my module supposed to be? What's that name? Create a static struct to initialize the bindings of which are there. What is my module? That's what I wonder. Is it something that we did here? Because they have my module as well here. Oh, it just generates them again. How do I know? How do I know what went inside my JavaScript file? I guess I can open it. Just having a hard time figuring out. What is inside module? Shall we see? All of this shit here. And code is not here. Unfortunately, we haven't succeeded today, it seems. This is a shame. Let's try and use this one here. Define unexported encode string. This is kind of sucks. This kind of sucks. Kind of sucks as well. Yeah, I feel like we're just missing this bit here. Oh gosh. My string length was that. The only way I've called this method is using C-warp and C-call. Are you including string length and string size and exports the functions parameter? Yeah, maybe C-call is what we need. String length. Yeah, I kind of feel like the function is not being exported. That's the issue. Guys, we're going to continue this some other day. I don't want to spend the whole evening here, but we got, you know, we got quite a bit done today, I guess, right? So we kind of understand a little bit more how Emscripten works. What I haven't got past yet is figuring out how to properly export these C++ functions without having to write a C++ wrapper around every function that I have. So it would be nice if we can just do a free C++. This macro here seemed very promising, very, very promising indeed. But the only problem is that it's not really it doesn't seem to be exporting my function. Like I don't see this encode string function here in my JS file at all. So yeah, I mean, we're going to leave it here, but we're going to continue this some other day. I think my next stream will actually be on this because I do want to learn more about WebAssembly overall. But yeah, I mean, if this is the last stream before Christmas, I hope you guys have a very nice holiday. I'll try and post a video thanking everyone for tuning in, really, because this year has been really good for me. I've grown the channel so much. Like I think at the start of the year we probably had about 100 subscribers, and now we're nearly on 1,000. So yeah, thank you all for tuning in all the time and for continuously supporting the channel. Especially you, Peter and Slim. You guys, if you guys are still here. But yeah, I mean, have a good evening, and I'll see you guys some other day. Bye bye. Cheers. Bye bye.